So this video is a continuation of the previous one on cost behavior, and now we are looking at linear regression, another method that we use to calculate total costs. And each tool has got its own rules and how you can compute the total costs. So as per formula, we always have this: the total cost is equal to fixed costs plus variable costs. This is our general formula. So the approach linear regression takes is that it takes the equation of a straight line and relates it to this equation that I've shown you above. So the linear equation of a straight line is what we call a linear function. That's why it adopts this model, and that's what the linear regression is based on. So y is equal to a plus bx. So usually how it's taught in any mathematical course, usually they state the equation of a straight line like this, and then you start substituting the required components. So as of cost accounting, we also adopt this principle from the linear equation of a straight line, and then now we try to relate it to how to get the total costs. So the y stands for total costs. Take note of that. The y, I've been putting arrows. The y is total costs. That's what it means in this formula. The A stands for fixed costs. So follow the arrows, by the way, they will guide you. And then the B stands for variable costs. What about X? X is the number of units that of course you would want to produce. So like you will see the question and you understand what we will mean by the X is by the number of units that they want you to produce to get a certain total costs. So let's get into it and see the formulas that are what's this related to the linear regression. So just like in high and low method, there was a special way of getting the variable costs. In linear regression, there's also a special way of getting the B which stands for variable cost. Just take note of that. These are the symbols we use in linear regression. The B stands for variable cost. So the model states that when getting this B or variable costs, the formula you use is this one. That's the one I'm writing on the screen. We use a statistical formula, as you can see, summation of xy minus summation of x summation of y. By the way, I'm just include an n at the beginning. Sorry, at the end there's an n, then over n summation of x squared minus summation of x in brackets, by the way, of there. So what you're seeing on the formula here is the formula for getting variable costs. Looks a little more challenging than high and low method, but it's very straightforward as well. So what happens is that to help us not make any mistake in substituting this formula, we create tables having columns with these components in the equation, so that once we are done with those tables, we'll just come and like substitute their totals into this and we'll easily find the value for B. So what I would do is that first let me give you the formulas that are related to linear regression. That's when we'll look at an example. So that's how you get the variable cost or the letter B in linear regression, because B stands for variable costs. So in mind with that formula, right? Once you have your variable cost, you also need your fixed costs to get your total cost in general. How do you get the fixed costs using linear regression? So in linear regression, the fixed costs, in short, we use it so by solving this. The A, we said A stands for fixed costs. So the formula is this: summation of y minus summation of x over n minus b. So the B you're seeing the formula just stands for the one you had just solved the variable cost. So if it's wrong, then it will affect your A. So this is further simplified to this: y bar minus bx bar. What do these mean? In short, the y bar you're seeing there just simply means the summation of x. When you sum up the summation of y, when you sum up y, then divide that by n. That's why you've noticed this is like just a reduced formula. This one I'm circling right now is like a reduced formula of what is above there. So if you notice on above there is the symbol for summation. So that's what we actually meant. You sum y, then you divide by what? By n. Then what about x bar? X bar just simply means summation of x as well. You sum up the column that you make for x, all the x values available, then you divide by n. That's what this means. Huh? So what's going to happen is that we'll go through a question and all these will begin to make more sense. So this is how you get the fixed costs using linear regression. This is the A. And the B, if you rewind, that's how we get the variable cost, which stands for B in the linear regression formula. Then thereafter, you will be able to get your Y, which stands for total cost. Then you've answered the question that might be given in a given scenario. Let us look at the question now. So we will use the same example as of the previous video on high-low method and get to understand how to calculate the total cost of producing 550 units using the linear regression method. So as earlier stated in the video, those are the formulas associated with the linear regression. And now we've been asked to calculate total cost, which we said is our Y in the formula. So what we just need to calculate is what? The value for A and the value for B. Then we're done. So let's get underway and get those values. So what happens is that in the formula there was summation of x, y, and the like. So what would be your x, what would be your y? Your x is taken by the number of units. Please take note of that. Your x is taken by the number of units, and then your y is taken by the number of your cost. Sorry, your y will be your costs. So that you can easily substitute in that formula, which had summation of x, summation of y. That's what you need. So I'll write a small table on the screen so that you get to see what I mean by your x will take up all the values of the units. Then your y will be represented by all the cost values you're seeing on the screen, and then it will help us compute what? The value for b. So we're solving for b first. So b is equal to what? Summation of x, y, minus, I forgot an n in front, summation of x, okay, summation of y, open, over n, summation of x squared minus summation of x, closing the brackets, then square there. That's the formula we're working with to get b. So you've seen in the formula there is xy, there is x, there is y. You know, you'll be wondering how we're going to come and put this well without making any mistake. The safest way is you make columns for each and every category which is there stated in the formula. So like there's a part which is written as xy, right? Meaning you should make a table which should have this column so that, you know, when you have this column, you easily apply this rule of summation of xy so that it's easy to come and substitute when you get to the formula. Then make a column for ex, summation of x alone. So make a column for x. Also make a column for what? For y separately. Then you get like their summation. So this means, of course, after you get their summation, then you multiply. That's what this part means for summation of x, summation of y. You get the sum of x alone, get the sum of y alone, then you multiply the two figures. So that means below there is an n. What does n stand for in this formula? Both up and below there is an n. The n just stands for just the number of times these costs were collected. In a week, they were only collected for 7. So this is 7 weeks, just for 7 weeks. So that's the n. The number of times something is done. In this time, they only used 7 weeks. So that's our n. Yeah. So we look at this part, summation of x squared. That x squared there just means you get a column looking like that, x squared. You make a column for x squared, meaning all those elements which are in the x column, all those unit values, you'll be like squaring them and you make a new column called x squared. Once you're done with that column, you sum it up and that's what you substitute there. Then now you want to make this column for the last part now, summation of x. Summation of x, what does that mean? You sum up the x column, all of it, the one which is being represented by the number of units, you sum it up. After you get the answer there, the summation, then you square. That's what this last part of the formula states just below, the one I'm underlining here. It just simply means you sum up x, the total you get, square it. Then you're done. You just substitute in that formula. So you just need to create a table having columns like this. Let me just illustrate this on the screen. So you have a column for your x that I was talking about, you have a column for your y, you must have a column for xy, because it's part of the formula, because you're just trying to relate to the formula so that it's easy to substitute. Then you should have a column for x squared because it's part of the formula as well. Once you get all these, trust me, they are enough to go and substitute in the b equation. Then you list everything, like your units, whatnot, like the x is being represented by all the units in the question, the y is being represented by all the costs. So I'm just like showing how you would start it up. 200 for the units there, the cost was 35 at that line, and you would list them like that. The next, I think the next units was about 300, the next cost was like 400. That's how you'll be recording 4,000, I mean. Then what about your xy? In your xy, you'll be like every x value by a y value. So it'll be like 2,000 by 35, you record something, and you know, and the like. What about in the x squared column? What do you put? Every x value, you start with the first one, the 200. You square the 200. What does it give you? I think it should be about 4 million something. That's what you'll be putting until you list everything. Then you get their summations. Because in the formula, you've noticed there's summation of what? Summation of this column, summation of and that not and whatnot. Then you easily get your B. So I'll just run through quickly and I'll just give you like the overall findings for this, since now the concept has been explained by the, let's say, this video. So take a look at the screen of what I meant. Like you make your columns as well for x, or we said x is being represented by the units. Okay, you even indicate such on your tables. Your costs are being represented by the y. And you know, once you sum up all these things, it will be very easy to take it into those formulas, having explained like that in the earlier part of the video. And then, you know, once you're done with all that, you'll be able to get your B. Let me just show you the final answer. You should arrive at your B after you draw this table, because after this table, you just be substituting. Trust me, it will be very straightforward. So it will be like, you know, let me just erase this on the screen. After you've done your tables, now then you now get to substitute that. You know, your B now, at the end of the day, you should get 10.43. That's your B. So you will say your B is representing what? Variable costs. Take note of that. Your B is your variable cost per unit, meaning whatever unit you'll be given in the question, like, you know, we want to now produce so much. You'll be like, you multiply this amount, this 10.43, by the units, and then you of course add to fixed cost to get your overall total costs. So we've gotten the variable costs. How about fixed costs? Because it's a component as well. It's a component of total costs. So we are left to finding fixed cost, which is the A in linear regression. So the A is equal to what? We said A is equal to, when reduced, we said y bar minus bx bar. This is the reduced form of that equation which I had stated earlier on in the video. What does y bar stand for? Y bar stands for the summation of y. What do I mean? Imagine you have your column for y, right? Summation for y, then you divide by n. So once you have like your column for y, right, you would sum it up with all your values there, whatnot, then your last answer here, right? Okay, your last answer there, I've just put like with 2 pluses, for example, you get your last answer there. Then that answer, the summation, that's the summation of y, the answer that comes at the bottom, then divide that by n. We said n is the number of times that, you know, this data was collected. Like this was done on a 7-week period. So that's your n. So that's the n would be like the total of y divided by that n, which is 7. So you find that according to the question we're actually solving, the y came out as 45,300. Then you divide it by what? By the n, which is 7. That's how you get y bar. This whole part, I'm writing in a circle, represents y bar. Then after that, minus what? Minus b. You've gotten your b from the previous equation we just wrote on the screen. Your b came out as 10.43. How about x bar? What does x bar stand for? X bar is very similar as well, like the way we did for y bar. X bar simply means the summation of x divided by n. Summation of x, that column for x, you sum it up, then you divide by n. So you'll find that the X column, let me just erase a bit of the screen. The X column had about a summation of 3,500 when you sum up the whole X column. Yeah, if you rewind, there's that table that I shared, how things had to come out. You'll see the values there, and you'll see this 3,500 right there in the X column as a total. Then we said divided by N. N is what? N is 7. So it's like going to be 7, 3, 5 divided by 7. Then you get your X bar. And thereafter, you would substitute in your general formula here, and you compute your fixed cost. It's that simple. Trust me, you should get, I think, an answer of 1256 point, I think somewhere 43, somewhere there. That's your answer for the A of fixed costs. Remember, your A stands for what? Fixed costs. So you've gotten all your components for total cost, right? You have your fixed costs now, you have your variable costs. How do you get total costs? Using linear regression. So in linear regression, total cost is equal to, we said y a plus bx. It adopts that equation. So we said already the A stands for fixed costs, so just take note of that. So it will be like your fixed cost is 1256.43, the one we just found, plus your B. What's your B? Your B was 10.43. Remember, this is a per unit price, meaning 1 unit costed how much? 10. How about X? X is the number of units that you want to produce now. They have told us in the question that they want to produce 550 units. So we already know what we're going to substitute on X. We said X is the number of units that you want to produce at a given time. That's what X stands for in this equation. So they want to produce 550, and that's what you substitute on your X. 550. Thereafter, you should be able to compute your answer and get your overall total costs. Should be about 69.44 points, yeah, point something, I think 0.93 if my calculator doesn't punch the wrong thing. Yeah, but that is your total cost. So the whole point is just to try to get the concept. Yeah, but basically that's how that example should have been solved, the one we've shared in this video. And that's all about linear regression as a part of a method that we use in calculating costs in this topic called cost behavior.